Hello everyone, I am Hanuman and today we are solving a very popular binary search problem, the LeetCode problem number 74, search a 2D matrix. In this problem teaches us how to apply binary search in matrix efficiently. So the problem statement is like we are given a 2D matrix where each row is sorted and the first element of every row is greater than the last element of previous row. So basically we need to check whether a target exists in the matrix. So the first example, you can see we have given an matrix array in which so using this image you can see we can easily understand. So the row is in a non-descending, it means in ascending order. So all the rows are in ascending order, so you can see 1 3 5 7 and 10 11 16 20. So and the target was 3 and output comes true because 3 exists in the matrix. And in the second example we can see the target is 13 and so we cannot see the value 13 in the matrix, so the output comes false. So now so if you look carefully, the entire matrix behave like a sorted 1D array, or so we can directly apply binary search in this problem statement. So let's move to the uh, solution part. So now we are going to solve by declaring int row and int columns. So int rows equals to matrix dot size. So the rows are holding the matrix dot size value, and the int columns is storing the dot matrix index 0 dot size. So now this is holding the columns value, and now we are again declaring int left equal to 0 and int right equal to rows into column minus 1. So this will be the value of right. Left is equal to 0 and the uh, right is equal to rows into column minus 1. Now we are using while loop in which if left is less than equal to right, then we have to initialize int mid and another variable which is used for we are assigning it that left int mid equals to left plus right minus left divided by 2. So this is the basic approach of binary search in which we are finding the middle value, and now we are using an integer variable which is named value, and the value holds the value is equal to matrix index of mid divided by columns and mid. Okay, mid modulus columns. And now we are again checking if a value is equal to target, then we have to immediately return true. Okay, if the value equal to target, then we are returning true. Else else if value is less than target, then we are increasing the left value by adding mid plus 1. Okay, so else if condition, if value is less than target, then left equals to mid plus 1. Now the else condition, in which right is equal to mid plus 1. So here, sorry, right is equal to mid minus 1. So here is the solution, and at the end we are returning false if the conditions all are false. So this is the solution. Now again I will explain line by line of each code. So the first int rows and int columns are storing the matrix dimension, and the second step, which is int left and right, are for binary search range. So treat matrix like a 1D shorted array, and the int mid equals to left plus left, so right minus left divided by 2, is for standard binary search. And and this in the value, int value, the matrix mid minus, sorry, mid divided by columns and mid modulus columns. This is the most important trick, where the formula row is equals to mid upon column, and column is equals to mid mode column. And next, the if condition, if value is equal to target, and then we are returning true. Else if it is not true, then we are moving to else if condition, where target value is greater than value, then we are adding 1 in the mid, so, and assigning it to left. And else uh, right is equals to mid minus 1. So this is a classic binary search um, method, and at the end we are returning the false. So this is the solution, and now we are going to run this and check the or both the cases have been passed. So now we are going to submit this solution and check the time complexity and space complexity. So our solution took 0 ms and beats 100% solutions, and space complexity is also fine. So this was my solution. Thank you for watching my video.